Hello everyone, my name is Eduardo Martinelli. My group mate is Nicholas Stow, our mentor is Dylan Murphy, and we are the Evolving Housing Market Group. For our group capstone project, we want to analyze and predict housing price values in the state of Arizona. We will achieve this by using several factors like state tax, crime rate, poverty percentage, population estimates. We will then take all these features and put them into a random forest model and Kearse model. Then we will see which model runs faster, and we will be uploading all of our graphs and results into an RShiny app. Our task is pretty straightforward. We just need to search for data sets that include factors that we'll use for our correlation and predictive models. Then we will see which model performs better. And finally, we will upload all our graphs, plots, results, and interactive map on the Shiny app. For when searching for our data, for our features, we use Data Planet, which is a database that we've found through the U of A library. And for Target, which is our house market index, we got all that data from the website Zillow. All our CSV files from Data Planet look like the file here on the left. We then cleaned it and merged it into one file, which looks like the one here on the right. The merged file on the right, each column includes the county of the state of Arizona, the year of that source, that county source, so ranging from 2000 to 2021, and the county source is the factors that we're using for our target. And those factors are the total arrests, crime rate, population estimates, poverty percentage, and state tax for each county. For our correlation models, we have our cluster plot, which the data is partitioned into several clusters for a specific source using k-means, and it is represented in the plot. Each dot represents an individual row. The plot represents also two principal components, dim1 and dim2, for the data set representing different clusters at a year level. The x and y coordinate, dim1 and dim2, are in terms of principal components, which are linear combinations of the original data. On the right, we have our heat map, which we made for every county. And the heat map has a correlation between its features and its target. So here we could see Tucson HMI has a correlation, high correlation with party percentage, and a pretty decent one with population estimate. In this slide, we have our predictive models. On the left, it's our random forest model, and it comes from the Gila County. The Gini coefficients are between 49.7 and 0%, which tells us that there's a medium to low inequality amongst the values of the Gila County. On the right side, we have our Kearse model, and here we showed the training and validation loss for Pima County. We can see that each epoch decreases the training loss. However, the problem is the validation loss is supposed to be almost merged with the training loss to tell us it's an accurate model. We can see on the 40th epoch that it starts to run off on its own. For our Shiny app, we created an interactive map of the state of Arizona. Here there's a drop-down menu for the year, factor, and county. So if you choose total arrests on the year 2000 and you put your cursor on top of the county, it outlines that county and it tells you the value. We also included 3 other tabs, cluster, forest, and heat map, and these tabs include the graphs that I showed in previous. For our predictive model results, we definitely chose the random forest for it had the higher accuracy compared to the Kearse model. Our Kearse models usually had an accuracy of 58 to 16%, which is not too great, while the random forest had accuracy levels between 60 and 80%. We also noticed that the MSE values were the same between both models and for each county. We learned a lot throughout our group capstone. Definitely how to be better at our organization and communication in group environments. Also, the biggest takeaway was definitely challenges in the integration of Python and R files, and also the lack of house market data, which had a huge impact in our predictive model accuracy. And that's our presentation. Thank you for watching, and I hope you enjoyed.